Okay, in this video we are going to learn about light energy. So after this study, you should be able to 1. Infer that light is a form of energy, identify different sources of light, explain that an object can be seen when it reflects light, demonstrate that white light is made up of different colors, describe the information of rainbow colors, explain the terms transparent, translucent, and opaque. Last, distinguish among transparent, translucent, and opaque materials. So, without wasting much time, let's start. Light energy. So, it is extremely difficult and sometimes impossible to see in a dark room. When light falls on our object, it bounces back, and as the rays enter our eyes, we are able to see the object. So now, what is light? Light is the energy that helps us to see. Right? A specific light beam called laser can even be used to cut steel and metallic materials. Okay, now during the day, see that during the day, the sun is man's primary source of light. It is a natural source of light. This is because, and this source of light is the main source of energy that enables green plants to prepare their food. Now, do you know that the insects, glowworm, and firefly give out light? Fireflies and glowworms are therefore examples of natural sources of light. Do you know of any other natural source of light? Usually, at night, we are able to see because of bulbs, candles, torchlights, and sometimes bonfires. These are artificial sources of light. Can you give me some examples of artificial source of light too? Okay, so we have two types of source of light. We have a natural source of light, natural sources, as we said earlier on, natural sources, and we have artificial source of light, and we gave examples. This one made by God, and then artificial made by human being. Okay, we gave the example that fireflies, glowworm, and etc. Artificial bulbs, candles, torchlights, and then sometimes bonfires too. They are the artificial source of light. So now let's learn how light travels in a straight line. Have you observed that anytime an object stands in the path of light, a shadow is formed? Can you explain why? This is because light is in a straight line or a path called rectilinear propagation of light. So now we are coming to do experiments to show that light travels in a straight line. And so the aim of the activity is what? To demonstrate that light travels in a straight line. And then the purpose, that's the aim rather. And the materials too. What do we supposed to get? We are supposed to get 3 cardboards. And then a string. And then a source of light could be candle too. So procedure. Lay the 3 index cards together in a straight line as shown here. Make a hole through all the cards at exactly the same position as I have done it here. The holes, exactly the same position. And then stand the cards in a vertical position and make sure they are about 3 centimeters. Okay. So place a bulb about 6 centimeters behind the last light. See, there is it. And then look through the holes. So you look at here. And then, can you see the light? So if yes, now move the central card slightly out of the line. So we are going to move the central, this one, out of the line. So we will shift this one up so that the holes, we will shift it up slightly. Okay. So the light is coming from here. So these are the holes. Can you steal the light? Can you still steal the light? So after all these things, we are coming to learn something. So let's draw our conclusion. When we put the cardboard in the same position and then we slightly moved it, what did we observe? So observation, if you had done this correctly, you will observe that when you look through the holes, you can see the light which is behind when they are arranged like this. Okay? However, when the middle card is slightly moved like this, when it's slightly moved as we did earlier on, and it's slightly moved like this, okay, when it's slightly moved, the path of light, this path of light is what? Is blocked. And since light travels in a straight path, the light is no longer odd. So this is the simple experiment I will demonstrate to you. So this one, the formation of shadows and eclipse are proof that light travels in a straight line. How shadows are formed and how eclipse too are formed. They are the proofs or the evidence that light travels in a straight line. So let's define some terms. Transparent objects. Transparent objects are objects that allow light rays to pass through them easily. Example, air and water. Transparent objects are objects that allow light rays to pass through them. And then translucent objects. Translucent objects are material that allow only small amounts of light rays to pass through them. And then most of the light which falls on them is scattered. So example is polythene bag, and then this colored plastics. Okay. Now, did you observe any light when you attempted viewing through any book? No. Now, so if you realize that you did not see source of a light at all, then the book is said to be what? To be an opaque object. So opaque objects are objects that do not allow light to pass through them. For example, wooden tables, stones, and human beings. And opaque objects too reflect or absorb all the light rays. That's why you cannot see what is behind if you are looking through wall or a human being. Okay. So let's discuss reflection of light. When light hits any surface like this, it bounces back just like the way a ball bounces back when it hits a wall. So the bouncing back of light when it falls on an object or a surface is called the reflection. So when you are using a football and then you bounce it on a wall, it will bounce back to you. So the bouncing back of light, in the same way, the bouncing back of light when it falls on an object or a surface is called a reflection. So this process is important because it allows objects to be seen. So this is a diagram of a reflection of light. So when a light is coming from this side, we call it what? Incident ray. A ray is coming from here, incident ray. And then this is surface of reflection. So it will bounce and it will hit this surface. And then it would reflect. So that line is called what? Reflected ray. And then this straight line is called normal. And then this angle, the angle here is called angle of incidence. And then angle here R is called angle of what? Reflection. Okay, so the ray of light that hits the surface is called incident ray, while the ray that bounces back is called reflected ray. The angle of incident ray, this is the angle of incident ray mixed with the normal, this is the normal, is called the angle of incidence, while the angle of reflection is the angle, the reflected ray mixed with the normal angle, the reflected ray mixed with the normal. This is the normal. So please, a ray has an arrow or a direction. Okay. Sometimes the rays of light may bounce off from a smooth surface or a rough surface. So regular reflection occurs when light rays fall on smooth or polished surfaces such as plain mirrors or glass. And then irregular or diffuse reflection occurs when light rays falls on rough, dull or unpolished surfaces such as tables, books, and then bags. So this diagram A, diagram B. The diagram A corresponds to regular reflection. So it's smooth surface. This surface is smooth or polished surface. And diagram B corresponds to diffuse or irregular reflection. It means that you see this one is going this way and then it will bend because the surface is unpolished or it's not smooth. And then this diagram, then the ray will and then reflected this way. But this one is diffuse. The ray coming this way, going the same direction, and then the same direction. So these are the types of reflection we have. We have two types: the regular reflection and the diffuse reflection or irregular reflection. The regular reflection and the diffuse reflection. Okay, so let's go to the laws of reflection. The incident ray, the reflected ray. One is the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. So this is the incident ray, the reflected ray, the incident ray. So incident will be noted by I, and the normal is N, and the R is the reflected ray, and then S is the surface. So incident ray, reflected ray, and the normal all lie on the same, at the point of incidence, on the same what? Surface or the plane. See the incident ray, reflected ray, normal at the point of incidence all lie on the same plane or what? Or the surface. So that's the law 1. And then law 2 says what? The angle of incidence is equal to the angle of reflection. So this is the angle of incidence. The angle of incidence is equal to the angle of what? Reflection. Are you okay with me? So if here is 50, the angle of reflected is 50, the angle of incidence will be what? 50 degrees. 50 degrees. Are you okay with that? So now let's go to the uses of reflection technology. Have you ever wondered about the relevance or importance of some of the things you study in classes, especially in science and mathematics? The study of the reflection and, for that matter, light has helped technology to make their life easier for us. So in science, anytime we study a topic, it is important to know the practical application of that knowledge or to think of how to use the knowledge acquired to design things that will benefit mankind. So this is called technology. So one use of the study of reflection is in the design of the instrument called periscope. So let's write periscope on the board. So one of the use of the reflection in the instrument called periscope, 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 the instrument called periscope. Okay, now let's describe. The periscope consists of two plane mirrors inclined at a vertical at an angle of 45 degrees. So I think it will be necessary for us to draw the periscope. So let me draw the periscope on the board for you. So the periscope is on the board. Okay. So now, this instrument enables one to see things that are high up or even hidden behind obstacles. Okay. So let's discuss the importance of the periscope. 1. In a double-decker bus, the periscope can help the driver who is at the lower deck to see and observe the activities of passengers in the upper deck. And number 2, when submarines are under the sea, periscopes enable mariners to see what is happening on the surface of the sea. And also, people who are short can use the periscope to watch events such as a football match. So this one will bring us to the end of the lesson. In the next lesson, we will learn something under refraction of light and white light ray. So subscribe and stay tuned.